Welcome to Unit 7, Sequence Series, Lesson 1, Arithmetic Sequences. Learning goals today, I can and will understand the properties of arithmetic sequences in its general term, find any term given the general term, determine the number of terms in a defined arithmetic sequence, and find out any term of sequences given any two terms of an arithmetic sequence. Here we go, let's go. So here are a couple examples of sequences. So before we actually define what a sequence is, here are some examples. Let's see if we can figure out the next three. So here I got 5, 7, 9, 3, 5, 7, 9. So clearly the next one will be 11, then 13, then 15. How did I do that? I saw the pattern of adding 2. Next one, 1/2, 2/3, 3/4, 4/5. The next one has to be 5, 6, then 6 sevenths, and 7 eighths. How did I do that? I just kept adding 1 to the numerator and denominator. Last one, 2, 4, 8, 16, and I also have 32, 64, and 128. Here I saw that I was multiplying by 2 each time. These are all examples of sequences. Why? Well, what is a sequence? A sequence is an ordered list of numbers. And so, as we can see here, down here, these are all ordered lists of numbers. Next thing, arithmetic sequence. So we're going to talk about this. This whole lesson is based on the arithmetic sequence. What does that mean? That means a sequence has the same difference between consecutive terms. There is only one here, down the bottom here, that's an arithmetic sequence, and that is this one. Why? Because there is a common difference of 2. I keep adding 2 to get to the next term. Same thing here, plus 2, and then same thing here, plus 2. Now, Mr. Wills, what about this one? You're adding 1 to the numerator, 1 to the denominator. I am, but there is no common difference between the two. And we'll look at that in a second. Term is a number or variable in a sequence. And finally, general term is express each of the terms of a sequence as a function of its position. So this is really, general term is really a fancy way of saying the formula. All right. So let's continue. We'll define a few more things. So here's our formula for an arithmetic sequence. So formula for arithmetic sequence looks like this guy. T of n is equal to a plus n minus 1d. Let's define all these. A, just like our last unit of exponential functions, is the first term of the sequence, and we can also call that t1. D is a difference between consecutive terms, so we can say d is tn minus 1. What's tn and what's tn minus 1, Mr. Wolf? Well, that's basically any term here. So, for instance, I can take any two consecutive terms, let's say 3 and 5, subtract them, always the bigger term, so t3 minus t2, and if I do that, I will get 2. Same thing here, 9 minus 7, and you can see that my consecutive terms here, the difference between consecutive terms is always 2, so that would be my d value. Next, n is the number of terms in the sequence. Tn is either the nth term, so the general term here, Tn, or we can also know it as the last term, so also known as the last term. We also know here, so d is equal to t2 minus t1 or t3 minus t2, doesn't really matter as long as you do consecutive terms, subtract them. Also, finally, just about this Tn, so this guy here will also be known as Tn because it is the last term. So either Tn is a general term or Tn is a last term. Let's do a few examples here. We're going to start off with a mild example. So here we go, mild. Given the arithmetic sequence 3, 7, 11, find Tn. So this just means general term. What about the last term, Mr. Wells? No idea. So what we're going to do here is the general term, and I apologize about that terrible writing. So here, let's try it again. General term. So here I know my a value is clearly 3, it's the first term. I know my d value, take any two consecutive terms, subtract the second minus the first, so this would be t1, t2, t3, so here I'm going to do t2 minus t1, and here I'm going to have d is equal to 7 minus 3, so d is equal to 4. So I have a and d, and so that means my general term will just be Tn will be equal to 3 plus n minus 1 d. And there we go. That is my general term. That's the question. Next one, here we go. We're going a little bit more spicy, so we're going to go medium, mild. Given the sequence 5, 10, 15, 125, find the number of terms in the sequence. So I want to solve for n. That's my unknown. So here I can clearly see again, a is 5. My d will also be, well, t2 minus t1, so 10 minus 5, which is 5 as well, okay. And I also know my tn here. My tn is 125. Why 125? It is my last term. Alright, so let's plug in my formula. Here we go. I know tn, so 125 is equal to a plus bracket n minus 1, and here my d value is, whoops, well, my d value is d. So I know my a and my d, so 125 is equal to 5 plus n minus 1 times 5. Let's bring this 5 over, so I got 120 is equal to n minus 1 times 5. Divide out that coefficient of 5 from both sides, so I divide out 5 from there, 5 from there. 120 divided by 5 is 24, so 24 is equal to n minus 1, so that means n is equal to 25. Therefore, there are 25 terms in the sequence. Alright, let's continue. We're going to go a little bit medium spicy here, so a little more spicy. There we go. T7 is equal to 14, T3 is equal to 6. Find A and D. Alright, here we go. Here's my suggestion. Make two equations, use substitution to solve for A and D. So I know T, let's go with the smaller one. So I know T3 is equal to 6. That means my N is 3. So I'm going to have here 6 is equal to A plus 3 minus 1D. So 6 is equal to A plus 2D. My other one will be this. I know T6. Oops, not T6, sorry. I know T7 is equal to 14. That means that 14 is equal to, well, also I know that n is equal to 7. So A plus 7 minus 1D. So here I've got 14 is equal to A plus 6D. So I have two equations, two unknowns. I'm going to stack and attack. What do you mean, Mr. Wells? Well, because I can see that they both A's both have a coefficient of 1, if I stack them, like so, and because they're both the coefficients both positive, I can subtract. So here I get 14 minus 6 is 8, and then A minus A is 0, so we're doing a little elimination here. 6 minus 2 is 4, so 4D. So here I can see D is equal to 2. How do I get A? Well, let's plug it back into here. So now I know, whoops, 6 is equal to A plus 2 times 2. So 6 is equal to A plus 4. So A is also equal to 2. Alright. There we go. And let's the last example. Let's go to the most spicy one. Here we go. So T10 is equal to 104, T26 is equal to 328. In an arithmetic sequence, find Tn, so the general term, and find T15. So here we go. We're a little spicy. This is as spicy as it really gets here. So I know, again, we'll do two sides here. So I know that T10 is equal to 104. That means that 104 is equal to A plus 10 minus 1D. So 104 is equal to A plus 9D. Over here, the other side, I know T26 is equal to 328. So I know that 328 is equal to A plus 26 minus 1D. So 328 is equal to A plus 25D. All right, well, let's stack and attack again because the A's both have a coefficient of 1. So I'll do that down here. So I know that 328 equals A plus 25D, and 104 equals A plus 9D. Subtract them, so this is going to give me 2, 2, 4 is equal to, subtract these, I get 16D. Alright, so divide both sides by 16. Let's divide this side by 16, oops. Divide this side by 16, and here I get D is equal to 14. I'm going to put this into, I'll do the smaller one, so put it into here, so that I know that 104 is equal to A plus 9 times 14. So 104 is equal to A plus 9 times 14, 36, so that would be 126, I believe. Bring this over, so I bring this guy over here, so I know A is equal to negative 22, because 104 minus 126 is negative 22. So I got my A and my D, so that means that, we're going to get the colors here, well, let's do this. So Tn is equal to negative 22 plus n minus 1 times 14. Also, T15 is equal to negative 22 plus, now here I want 15, so it's going to be 15 minus 1 times 14. So if I plug this in my calculator all in one go, I get T15 is equal to 174. So here are my two answers. Answer 1 and my answer 2. And that's all she wrote. All right. So, a few notes about this. Going back to, I believe, this slide here, I just want to make a few things here. So A is the first term, D is the difference between consecutive terms, N is the number of terms in a sequence, Tn is the nth term or last term. N here, one comment I would like to make here is that N is the number of terms in a sequence, and there is actually a stipulation on this. N must always be greater than or equal to 1, and N also must be integers. So that means it has to be 1, 2, 3, 4, 5. You can't have a decimal number of N. So if you solve for N, you get a decimal number, something went wrong. All right, homework. Here it is. I don't think there's really any difficult questions here. Determine the recursive formula. Don't worry about recursive, so just determine the general term of an arithmetic sequence. Don't worry about recursive formula. But I think that is it. Really, 13. Nothing here is really difficult. Again, 13 is finding how many terms there are. And that is that.